All right, here we are ready for example 1. So we always start out when it says solve a triangle. We learned that that means I need to find all the answers. So I need angle A, angle B, angle C, and I need side A, side B, and side C. Again, one of the most important things to do is to be able to label your triangle so you know that you're putting the right numbers in the right spot. So I definitely have angles right now of A, B, and C. Across from big angle A is little side A. I don't know it. Across from big angle B is little side B. I don't know it. Across from angle C is little side C, and I do know angle side C is 20. Angle A is 40, and angle B is 60. All right, just like on our right triangles, if we're trying to solve, they have to give us 3 pieces of information, and now we can now solve for the other 3. So the key is, do we use law of sines or do we use law of cosines? Well, the first thing I notice, if I know 2 angles, I can find the third, and I'm going to do that first before I start anything else. 180 minus my 40 and my 60. Well, 40 and 60 is 100, so I get 80 degrees for angle C. All right, my 3 angles are there. And now when I go to choose my law, I'm looking first, do I have a side and angle combination that are of the same letter? And I notice, now that I found that 80, I do. I have an angle and side of the same letter. Because I do, I can use law of sines. Okay, so I'm going to choose law of sines because I have a side and an angle of the same letter. And I know I need to choose 2 of them. Well, the one I'm going to definitely start with is sine C over C because I know both of my C's. So I'm going to start with sine C over C, and now I just need to make a choice. What do I want to solve for? I can solve for A or B next. It doesn't matter. I'm just going to start with A since A comes first, but if you start with B, that's fine. There's my formula I'm going to use. I only use 2 at once. I can't use all 3. And I'm going to start plugging and checking what I know. So I have sine of angle C. Well, angle C is 80 degrees. Side C is 20. Sine of angle A, well, angle A is 40 degrees over side A, which I don't know. Okay, I need to get A by itself. I want to solve for it. Well, currently it's in the denominator. Just a quick hint, when you're working with a proportion and your variable you're looking for is in the denominator, cross multiply. Get it so there's no denominators, right? So we're going to cross multiply. I'm going to get A times the sine of 80 equals 20 times the sine of 40. I always like to put what I'm multiplying by in front and my signs at the back so that what I'm multiplying by doesn't get confused with my angle. All right, I want to get A by itself. What's connected to A? Sine of 80. So what do? I divide both sides by sine of 80. Remember, as long as there's an angle there, we can divide by the sine of 80. It's really a number programmed in our calculator. This cancels, and I'm going to get A equals 20 times the sine of 40 divided by the sine of 80. Thinking back to what we did in chapter 7, this would be kind of my standardized test answer, which means I'm now ready to go to my calculator. Make sure your calculator's in degree mode, and you're going to type 20 times the sine of 40. Make sure you close your parenthesis after the 40, and then you're going to hit divide by the sine of 80. And I get about 13.1 for that side for A. So 13.1 for A. All right, I have one more to go. Now, I have 2 sides of my triangle. Can I use Pythagorean theorem now? No. I don't have a right triangle. I cannot use Pythagorean theorem. It can only be used on a right triangle. So I'm right back to my law of sines again because this is a way to find sides of triangles that are not a right triangle. So I'm going to do sine of C over C again because that's the 2 I started with. But this time I'm going to go to sine of B over B because I'm looking for side B. So again, plug and chug. In for angle C, I type in 80. In for side C, I have 20. In for angle B, I have 60. In for side B, I don't know. Once again, if what I'm solving for is on the bottom, I don't want to leave it in the bottom. I don't want anything in the bottom if I can, so I'm going to cross multiply. I get B times the sine of 80 equals 20 times the sine of 60. Again, you could go to your calculator and get these decimals, but then you have to remember them and leave them in 4 decimal places. I just keep going until I get B by itself. Right now, B is being multiplied by sine of 80, so I divide by sine of 80. What I do to one side, I have to do to the other. It's so important to leave the sign on there because that symbolizes it's a decimal it's standing for there. And I get b equals 20 times the sine of 60 divided by the sine of 80. Make sure when you type that in your calculator, you close the parenthesis after the sine of 60. So 20 times the sine of 60, close that parenthesis, divided by the sine of 80. And I get about 17.6 maybe when I round that. All right, so I get 17.6 for B. Okay, quick check just to say, do my answers make sense? Is my biggest angle across from the biggest side? 80 and 20 are both the biggest. Is my smallest the 40 across from the smallest side, the 13.1? Yes. So my answers make sense here. And that was using law of sines a couple times. And you will find you're going to have to use your laws more than once to get through these problems. All right, let's go to our second example. All right, in this one it says find the angle of the triangle, each angle of the triangle. Well, when I look, I already have all the sides. So it looks like I need to find those angles. And by the way, they have the triangle labeled DEF. It doesn't match my laws very well with A, B, and C. You're allowed to change them, okay? So don't be afraid to just cross one off and make it A, cross one off and make it B, cross one off and make it C. That's fine, okay? Because they're simply labels and the law needs to work with the letters. And so it doesn't matter even where you put your A, B, and C as long as you label them and you make sure side A is across from your big angle A. Side B is across from your big angle B. And side C is across from your big angle C. Okay? Make sure that's what's the same, and then the answers we get will match at the end. Okay? So I am got to find them all, right? A, B, and C. I already know little side A on my picture is 12, little side B is 32, and little side C is 40. Okay, I'm finding my angles. All right, so now I have to figure out which law do I want to use. Remember, if I want to use law of sines, I need an angle and a side of the same letter. I don't have any angles, so I can't have an angle and side of the same letter. I can't use that. All right, so that means I need to go to law of cosines, okay, because I don't have an angle and side of the same letter. Now the question is, which law of cosines do I want? And here's the quick answer. Any of them work. Which angle do you want to choose first? So just a quick reminder, law of sines cannot find me an obtuse angle, but law of cosines could. So sometimes if I have to start with law of cosines, I might go for that obtuse angle or what might be that obtuse angle, because if it can give me the obtuse angle, I don't have to worry anymore because I can only have one obtuse angle. So let's see. If I have an obtuse angle here, it would have to be across from my biggest side, which is 40. So if I have an obtuse angle, it has to be the C. So I'm going to choose this last one, but by the way, any one of them will work for this question, okay? So I'm going to start with C squared equals A squared plus B squared minus 2AB cosine C. No answer, no choice was wrong. I chose this one. You can choose whatever one you want. Okay, little side C is 40. Little side A is 12. Little side B is 32. Little side A is 12. Little side B is 32 times the cosine of angle C. Notice I had enough information and was able to plug in everything except the angle. And remember, anytime we're trying to solve, we don't want more than one variable left over. We want only one. So make sure you have enough information to fill in all the rest of the variables. All right. A lot of computations here. 40 squared is 1600. 12 squared is 144. And of course I bump stuff. By the way, that's a 1600. 144. 32 squared is 1024. Notice here, three things multiplied together. I'm going to keep that minus out front. 2 times 12 times 32. I get 768 cosine of angle C. Okay. Well, I can add these two. 144 plus 1024 gives me 1168. Okay. we need to be really careful with what's going on here and what we can do operation-wise. Can I take 1168 and subtract 768? No. Okay, and the reason is the 768 is connected to that cosine C. It's like saying 768 square root of 5. We know we can't join a square root with a non-square root. Well, I can't join 1168 with a term that has a cosine C because they're not like terms. So I cannot subtract those. Please don't. What my job is to start getting C all by itself. So the first thing I'm going to do is to subtract this 1168 over to the other side. Okay? So I get 1600 divided by 1168. Not divided by, what am I doing? Let's try that again. 1600 minus 1168. Sorry, I wrote the wrong thing in my calculator. I get 432 equals negative, because that negative is still there, negative 768 cosine C. All right, I'm trying to get C all by itself. Well, the next thing I can move is that negative 768. How is it connected to my cosine C? By multiplication. How do I undo it? Divide. All right, so I'm going to divide. This side cancels, and I'm left with cosine C. I know that 432 divided by negative 768 is not going to be a pretty number or a pretty decimal. So I'm going to just choose right now to leave it exact like this as just a fraction. My last step here, I want to get C by itself. What's connected to C? Cosine. How do I get cosine unconnected from C? What's the opposite of cosine of something? The cosine inverse. What I do to one side, I do to the other side. These two cancel, and C is going to be cosine inverse of 432 divided by negative 768. And I can't stress enough to you how important that negative is. Okay, so when you go to your calculator, make sure it's in degree mode. Inverse cosine, 432 divided by negative. Don't put the subtraction key, use the negative key on your calculator, 768. And I get 124.2 degrees. We'll round everything to the nearest tenth. So 124.2. Notice I got an obtuse angle. Good thing, because, and that is not A. I'm not going to be able to do that with law of sines. My calculator would not have been able to give me that obtuse angle. So 124.2 degrees, okay? Now, I'm looking still for angle A and B. I can't use any SOHCAHTOAs. I don't have a right triangle. But I can use another law. Notice I now have a side and angle combo. Because I don't have to use another law of cosines to find another angle. I can switch over now to law of sines. Because I have a C and a C, I'm going to start with sine C over C. And now it doesn't matter which angle I find. I know they're both acute. They have to be. I'm just going to start with A and A. All right, so sine. My angle C I just found was 124.2. Side C is 40. My angle A, I don't know. I leave that A. And side A is 12. Okay. I need to get A by itself. I have a sine and I have a divide by 12. I don't want to divide by 12, so I'm going to multiply both sides by 12 to get this away. And I get sine A is going to be 12 times the sine of 124.2 degrees over 40. You could have cross-multiplied. You end up having to divide back out by that 40, so I tend to just kind of skip that. But anyway, our job is to get A by itself. What's connected to A? The sine. What's the opposite of sine? Sine inverse. So what I do to one side, I have to do to the other. This side cancels. A is going to be the sine inverse of this great big chunk, 12 times the sine of 124.2 all over 40. Now, some quick reminders, because this is super important as you plug this in. I tend to put a parenthesis around my entire top, so I'll do parenthesis 12 times sine 124. Now, your calculator gives you the front parenthesis. Make sure you close that parenthesis and then close one more parenthesis for the top before you hit divide by 40. So that's inverse sine parenthesis 12 times the sine of 124.2, close the angle parenthesis and the top parenthesis, and then divide by 40. And I get an angle of about 14.4 degrees for angle A, which kind of makes sense when I look up there because it is a tiny angle if it's drawn to scale, right? Because if I drew it, it probably isn't. All right, we have one more angle to go. Law of cosines, law of sines, what do we use? I'm using my 180 rule, right? All angles add up to 180. So for angle B, if I do 180 minus the other two I already found, the 124.2 and the 14.4, I add those two together and subtract from 180. 124.2 plus 14.4 and subtract from 180, and I get about 41.4. All right. I believe I have all my angles. I already had all my sides. I've solved my triangle. Just a quick check. Is my largest side across from my largest angle? It is. Is my smallest side across from my smallest angle? It is. It's making sense to me. So I think we have that triangle solved. All right, next example. Find the missing sides and angles of the triangle. So otherwise solve this one and figure out what's going on. The figure is not drawn to scale. That's not a surprise. ABC, ABC. Let's see. Angle A, I don't know. Side A, I do know because it's across from A, and so that's 2 centimeters. All right. Angle B, I know is 98 degrees, but I don't know side B across from it. Angle C, I don't know, but I do know side C, which is 9 centimeters. Okay, so I know what I have, the 3 things, and I need to solve for the rest. So the question is, do I use law of sines or law of cosines? Well, I need to start with saying, do I have an angle and a side of the same letter? And looking at the 3 I have, I do not. I have an A, a B, and a C, but no A, B, B, or C, C. So I have to start with law of cosines. The question is, which law of cosines do I start with? This one is decided for me because I know angle B. And so that means I have to use the B equation because that's the angle I know. So I'm told basically by the information that I have to start with B squared equals A squared plus C squared minus 2AC, the cosine of angle B. All right, I don't know my B. Side A is 2. Side C is 9, minus 2 times side A again, times side C again, times the cosine of B. So once again, nope, I made a mistake there, didn't I? Okay, I do know angle B, which is 98 degrees. Okay, and that's what I was just checking for. I should be plugging in everything but one thing. And the one thing I don't have is side B, but I have all the rest. Okay, let's do a little math. 2 squared is 4, 9 squared is 81. All 3 of these multiplied together, 2 times 2 is 4, times 9 is 36. Cosine of 98 degrees. All is equal to my B squared. I can add those two and make it 85. But can I subtract 85 minus 36? No, because 36 is being multiplied times cosine 98. They got that extra part on it. Those two are not like terms. I cannot subtract them. What is my job here? What am I solving for? I'm solving for B, and right now it's B squared. How do I get it to just B? I take the square root, okay? So B is going to be the square root of 85 minus 36 cosine 98. And I'm going to be honest, your calculator can handle that. So as far as I'm concerned, I'm not going to do any more math. I'm just going to plug that in just like it looks. Square root of 85 minus the 36 cosine of 98. Make sure you're in degree mode. And I get a B of about 9.5. Okay. So B over here is about 9.5 centimeters. Okay. That's my law of cosines when I'm missing a side. That's an example of it. So now I need to find my other angles, right? And I know that because I now have a side and angle combination, the same letter, I can switch over to law of sines. Because I have B and B, I know I'm going to start with sine B over B. And whichever one I want to solve for next, I always double check, is there a chance I need an obtuse angle somewhere? No, because B was already obtuse, so nothing else can be. So I'm just going to go with A since it's the first one. All right, angle B is 98 degrees. Side B is 9.5. Angle A, I do not know. Side A is 2. Okay, I'm trying to get that big angle A by itself. So right now on the same side, I see a sign and I see a divide by 2. I'm going to get rid of the divide by 2 first by multiplying both sides by 2. I get 2 times the sine of 98 on top, divided by 9.5 equals the sine of A. What's still connected to A? Sine. How do I undo sine? Inverse sine. So I take the inverse of both sides. This side cancels, and A is going to be the sine inverse of 2 times the sine of 98 degrees divided by 9.5. All right, a reminder, you might need to do a top parenthesis, the calculator gives you in front of 98, close that and close the top before you divide by 9.5. So inverse sine of 2 times the sine of 98, close the angle parenthesis, close the top parenthesis, and divide by 9.5, and I get about 12.0 for angle A. All right. And I like to put that 0.0 to make sure someone realizes it does not come out equal. And I have this strong suspicion that this triangle really is not drawn to scale. All right, last one here for angle C. Law of sines, law of cosines. How about subtract from 180? That's the easiest. So C is 180 minus my other two angles, which are 98 and 12. All right, 98 and 12 together make 110 minus that 180, or 180 minus 110 is 70. And probably about a 70.0 again, too, if I did that one with the law of sines. Is my smallest side across from my smallest angle? Definitely. Largest side across from the largest angle? Yes. So it looks like my numbers make sense, even if my picture is not drawn to scale. All right, next example. My triangle is at least named ABC, that's good. Side A is across from big angle A, that's my 10. Side B, I do not know, and I don't know my angle B. Angle C, I do know, and side C, I do know. All right, and I'm solving, so I need an A, a B, and a C. I need a side A, a side B, and a side C. Angle A, I don't know. Angle B, I don't know. Angle C, I know is 62. Side A is 10 inches. I don't know B, and C is 18 inches. All right. One thing I do know, it just says for angle A, so once I get A, I can really stop here. I don't need to keep going. It didn't say solve the whole triangle. What do I have? Which law can I use? Well, I see my angle and side that go together. So if I have an angle and side that go together, I'm using law of sines. So I'm definitely going to use the sine C over C, since that's what I started with. And I'm going to be honest, sometimes you're limited to what else do you know? I know side A, so I can definitely solve for sine A, or the angle A, because I have the side A. If they would have only given us B, we'd have to find all the B information before we could go for the A information. So just kind of a heads up on that. All right, plug and chug. In for angle C is 62 degrees. In for side C is 18. In for angle A, we don't know. I leave it angle A. In for side A, I have a 10. Okay, trying to solve for angle A. It's on the top. I don't need to move it. I need to move things away. So I'm going to multiply by 10 to get rid of that divide by 10. So I have 10 times the sine of 62 over 18 equals sine of A. I'm going to get rid of that sine off of the A, so the inverse of sine will take care of that. What I do to one side, I do to the other. A is going to be inverse sine of 10 times the sine of 62 all over 18. Make sure you're careful that you close parentheses from the calculator if you want to do that parenthesis on top. Inverse sine of 10 times the sine of 62, close your angle parenthesis. If you did a top parenthesis, close the top parenthesis, divided by 18. And I get an angle of about 29.4 degrees. Okay, that's what I was looking for. So I actually get a stop right here. Otherwise, I could go and subtract to get angle B from 180 and then use that with law of sines to find side B. All right, 2 more to go. I'm going to start with what I know. This one does say to solve, so I'm looking for all answers again. A, B, C, and side A, side B, side C. All right. I know angle A is 15 degrees. Side A is straight across from that. I don't know it. Angle B is 20 degrees. Straight across from that is side B. I don't know it. Angle C I don't know, but side C is across, and that's 10. Okay, so I know what I have, and I need to solve for 3 more. Quick reminder, if you know 2 angles, that's a quick subtraction, right? Okay, 180 minus my 15 plus 20. Side C is, angle C is definitely going to be obtuse, isn't it? How about 145? All right, which is nice because I don't have to solve for any A's, or angles. Okay, I have an angle and a side combo, so as long as I have an angle and side combo, I can use law of sines. So I'm going to start with C and C since that's what I know. And just because I can, I'm going to start with A. You can always do the B. We'll end up doing the B. Angle C is 145 degrees. Side C is 10. Angle A is 15 degrees, and I do not know side A. I'm trying to solve for A. It's in the denominator. I don't like things in the denominator. I can't solve for them when they're in the denominator, so I'm going to do a quick cross multiply to get everything out of the denominator. A times the sine of 145 equals 10 times the sine of 15. I want A by itself. It's connected to sine of 145. Because I want to get rid of the whole chunk and it's being multiplied, I'm going to divide by sine of 145. Remember, that's really a decimal that's programmed in our calculator. So I have 10 times the sine of 15 degrees divided by the sine of 145 degrees. This is kind of my standardized test answer. I'm ready to go to my calculator. 10 times the sine of 15 degrees divided by the sine of 145 degrees. And I did not do that right. 10 times the sine of 15 divided by the sine 145. And I get about 4.5. And that's a side. Okay, remember, if I have 2 sides, I cannot use Pythagorean theorem because I do not have a right triangle. So we're right back to law of sines again. Again, I'm going to start with sine C over C. And this time I'm going to use sine B over B to find my missing side of B. So I get angle C is 145 over side C, which is 10. Angle B is 20 degrees over side B, which I don't know. Anytime I'm looking for something in the denominator, I need to get it out, so I'm going to do a little cross multiply. B times the sine of 145 equals 10 times the sine of 20. And I'm going to divide by that whole chunk of sine of 145 to get B by itself. So B is going to equal 10 times the sine of 20 degrees divided by sine of 145. Plug that in your calculator. And my missing side is about 5.96. I'm going to round that to 6.0. Okay. And again, the best way to check to make sure our answers are making sense is my biggest side across from my biggest angle. It is. My smallest side is 6, and it's across from the 20 degree. My smallest side is not 6. My smallest side is 4.5, which is across from 15, which is even smaller than my 20 and my 6. All right, last example. And there's no picture. All right, we can draw it. They were nice to give us ABC. Let's not draw that. There we go. Okay. Drawn my triangle here. I'm going to call it ABC. Remember, it's more to organize my information. Doesn't have to be to scale. So across from big side, or angle A is little side A, which is 20. Across from big angle B is little side B, which is 21. Across from angle C is little side C, which is 10. And I'm solving the triangle, which means I need all my answers. And it looks like I start with all sides. All right, oops, that's a 10. If I start with all sides, do I have an angle and side combination, 2 of the same letter to start with law of sines? No, which means I need to start with law of cosines. And I need to choose one of those to start with. Okay. Doesn't matter which one we start with. No, because it's what angle we're looking for, and we get to choose. We get to choose which one. We'll go with anything here. Which one would you like to choose? You want to go with A because we haven't used A yet? We can do A. Okay. A squared equals B squared plus C squared minus 2BC cosine A. We're plugging in everything we know. A is 20. B is 21. Little c is 10. Minus 2 times my b, which is 21, times my c, which is 10, times the cosine of A. 20 squared is 400. 21 squared is 441. 10 squared is 100. Remember, we can multiply these three together. 2 times 21 times 10. And that gives me negative 420, or minus 420 cosine A. Notice again, A is the only thing that's missing. Everything else we're working with here. Okay, we can add these two and we get 541. Remember, we cannot subtract that 420 from it because the 420 is connected to the cosine of A. So we start getting things away from cosine A. So I subtract 541. And I do get a negative number, and that's okay. Okay, so I have negative 141 equals negative 420 cosine A. I'm working to get A by itself. That negative 420 is multiplied in there, so we have to divide to get it to the other side. All right. Remember from earlier, I choose not to actually divide, but just leave that fraction. I will get rid of these two negatives because two negatives will divide to make a positive. So I'm just going to leave it 141 over 420. I need A by itself. What's connected to A? Cosine. What's the opposite of doing that cosine is the inverse cosine. What I do to one side, I do to the other. So A is going to be the inverse cosine of that 141 over 420. Plug that in your calculator. Make sure you're in degree mode. 141 divided by 420. And we should get an angle of about 70.4 degrees. All right. One angle down, two angles to go. And now we know that we have this angle and side that go together, so we can use my law of sines now. So because I have A and A, I'm going to go to that. I have angle B and angle C left. I probably should have started before and said, wait a minute, is there a chance I have an obtuse angle? Maybe. If I do, where would it be? It would be on angle B because it's across from the biggest side. So because there's a chance B is obtuse, law of sines cannot get me an obtuse angle. I'm going to skip that one and go to C because I know angle C is going to have to be acute. Okay? So we'll talk about kind of what we could do there the same. Let's plug and chug here. Sine of angle A is 70.4 degrees. Side A is 20. Angle C, I do not know. Side C is 10. I'm trying to get C by itself, so I'm going to multiply first by 10 to get that 10 off of that side. So I have 10 times the sine of 70.4 divided by 20. I want C by itself. What's connected to it? That sine. How do I undo sine? Inverse sine. What I do to one side, I have to do to the other. So C is going to be the inverse sine of 10 times the sine of 70.4. I'm going to give myself some more room here. All divided by 20. All right, remember, be careful on your parentheses. If you put a top parenthesis, okay, then it's 10 times the sine of 70.4. Close your angle parenthesis, close your top parenthesis, and then divide by 20. And I get an angle of about 28.1. And that was C. All right. So I have one more angle to go. You can use law of sines, but if that's obtuse, it won't find it. But the nice thing is I can do my subtraction. Squeezing myself, I'm going way up here to the top. So angle B is going to be 180 minus the other two I already found, which were 70.4 and 28.1. So 180 minus 70.4 and 28.1 leaves me with 81.5. So it turns out that I did not have an obtuse angle after all, so my law of sines would have worked. But if you're not sure, it's best to save it for the end where you can subtract or to use it with your law of cosines. So we really could have started with our angle B, so that would have told us right away. And sometimes that's the safe way to do it, is if you think there's an obtuse angle, solve for it with your law of cosines because it will do that, but law of sines won't. All right, I know this was long, a lot of examples, but hopefully you kind of see how the equations work and you can practice them. You are practicing 1 through 4 on the front of the worksheet, 1 through 4 on the back of the worksheet, and then you will let me know if you have any questions on those, okay?